Hello and welcome to everyone in Physics Fire. Today we are going to do electrostatic potential energy between two charges. Suppose there is charge Q1, there is charge Q2. So what will be, and the separation between them is R. Then what will be the potential energy that we are going to see? If you will see the formula before doing derivation, the formula is K Q1 Q2 by R. Guys, as we know, potential is a scalar quantity, so you will have to take charges with sign, right? So let's start. Potential energy due to a system of charges, also we can say two system charges. Now we are seeing, it's fine. So we can say potential formula is K Q1 Q2. The formula is what? K Q1 Q2 by R. That is going to be the potential. Charges with sign. Charges with sign. Okay, so let's see. Now potential, as we know, change in potential we can find. Directly potential is tough to find, right? We can't find directly potential. Change in potential we can find. So what we are doing, two system, let's say one Q1 charge and Q2 charge. This configuration of charge is at infinity. These two charges we are bringing, Q1 here, Q2 here at point P. So we can say this is initial position and this is what? Final position, right? Ultimately we are bringing a Q1 charge from all the way from here to here, then Q2 charge all the way from here to here, from infinity. So we can say there is initial position, there is final position. So always there is going to be what? Change in potential energy, delta U, that is equal to work done by external force. Work done by what? External force. Obviously we are doing from here to here, from here to here we are bringing. So change in potential, we can say potential at point P minus of potential at infinity. But obviously change in potential, a final point minus of initial point. So that is what I wrote. External, if you will see, guys, work done we learned is what? V, what is that? V is equal to W by Q. So V into Q is what? W. V into Q is what? W. So now we can say here, W is equal to what? V into Q. That also we can say. So let's see how we can do now. So we can say work done to bring a charge, first charge first. Work done by external force to bring Q1 plus what? Work done by external force to bring a charge Q2, right? Acha, we can say one more thing, that delta U is equal to work done per unit charge. If you will see Q1, if you will bring first Q1 from this configuration to ultimately this configuration, then there will be no potential, right? Why? There will be no work done because there is no charge at all on that configuration, right? Before the first charge which we are considering, that is Q1 only. So there is no there will be no work done by external force. So this is going to be what? 0. So work done by external force or due to on bringing the charge Q2 is equal to what? This infinity is what? 0. So Vp is equal to work done by external force in bringing Q2. Okay. One more thing we can say, Vp minus of V infinite is equal to work done by the charge Q2 to bring from infinity to a point P divided by what? Q2. Correct? That also we can do. So now we want to find ultimately this. So this shortcut you apply, you get answer. Now we can say Vp into Q2 is equal to sorry, work done by external force. right? So Vp is what? Potential due to Q1. So that is what? KQ1 by what? Distance R. We are having the potential till what? R into what? Q2 is equal to work done by external force. So ultimately the formula is Q1 Q2 by R is equal to work done by external force. So this is going to be the external force due to what? The potential work done by external force is equal to KQ1 Q2 by R. That's it. Again, remember, we are supposed to consider what? With sign. That is most important. Let's see now. Suppose three charges are Q1. Let's take all our Q1, otherwise it will be a problem. So Q, and Q. It is placed at the vertices of an equilateral triangle of side A, of side what? A. Now they are asking find potential due to this configuration. Find potential due to this configuration. So this question, if you will do, easy only. How? Potential is equal to KQ1 Q2 by R. It's kind of example. Suppose this is the area, like a big area there. One Don is here, right? He is a boss here. He is a boss here. Yes, right? He is a boss here. Suppose from outside, one guy is here, and then he wants to come inside this. So of course he will oppose him. He will apply potential. He'll have to give some energy to him, right? Some money, production money kind of. So same thing, what will happen? He will come inside anyway by taking permission, right? By taking permission, he will come inside. Now one more guy is there. After 1 year, what will happen? He will also become the local area don, right? So we can take like this. Again, one more guy is there. He also wants to come inside this area, right? Once he'll come here, right? So he will also apply, right? He will also apply, and he will also apply potential on this. Got it? Same concept is here. Suppose first we brought charge this, so and the second is this, third is this. So what will happen? First he will apply potential on this charge. So let's take Q1, Q2, and Q3. So we can say K Q1, Q2 by what? A. Then what happened? This charge came. This charge will come as he came here. The third charge, the third people came. So the bigger Don and the smaller Don both will apply, right? Potential. Say same thing here. He will also apply. He will also apply. So that is K Q2 Q3 by A plus what? K Q1 Q3 by what? A. That is going to be the net potential. As we know, charges are same here. So net potential is going to be 3KQ. KQQ is what? KQ square. KQ square by what? A. So that is going to be the answer for what? This question. Hope so you guys understand. By this way, you can understand easily. Let's take one more question. One more question if you will do. First what? A small triangle Q, 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 side is A. Now we convert to this triangle, a bigger triangle, right? Let's change the color. Now the side becomes 2A 2a. Q charges remain same. So they are asking find the change in potential. Find the change in potential, electrostatic potential, right? So that if you want to find, let's see how we can find electrostatic potential. Guys, let's find first for this if you'll see 3kq square by a, 3kq square by a, that is the potential. Let's take v1. Here is what v2 is 3kq square by 2a. So net potential easy now. So this was initial, this was what find. So net potential if you want to find, so ultimately v2 minus of what v1, so 3kq square by 2a minus of 3kq square by a, right? So that if you will do, then how much you will get? Ultimately this is 6a, so minus of what 2a and a, so it is minus of, let's see, we'll solve it. We can say 2a is the LCM, so 3kq square minus 6kq square, correct one, 3, so that will become 2 times, right? So 6kq square net potential, so it is going to be minus 3kq square by 2a is the net potential. That's it, guys. Till here we can say this topic we can cover. Like if you understood the formula, you do the numericals, it will be easy. Tough numericals will be there, but basics we can do by this formula as well as these numericals. We'll see in the next class.